In previous sessions, we discussed core concepts and fundamentals for Docker and containers, followed by the understanding of Docker components and operations. Later, we talked about real-world working architecture and we built our Docker environment based on the same architecture. Hello everyone, this is Atmaram and welcome back to my channel. In this session, we will perform proof of concepts for Docker build operations to properly understand the concepts by performing the following activity. So first of all, we are going to write a Docker file so that we can understand the sections and information those are included in a Docker file. Then we'll perform Docker build operations to convert the Docker file into images. That means what all the informations and fields that we have defined in a Docker file, we will use those information to create a Docker image. Then moving further, we will access Docker Hub registry that we had created in previous session from our Dockerized dev environment so that we can push the images. And at the end, we will perform image tagging followed by the Docker push operations to push the images to the Docker Hub registry. So without causing any further delay, let's jump onto our VirtualBox environment and let's get started.
First of all, let's open the VirtualBox and start the dev node, because we are going to perform build operation, and for that purpose we need to use dev node. Hit enter. It is booting now. Here we are. So my dev node is now running. I need to log in using our username that we had created, which is demo. And let's try to find the IP. What is the IP of the system so that we can access it from outside the VirtualBox console. This is the IP of the system, which is 192.168.56.104. I had already created one POC profile for this, so we are going to use it. I will show you. So I'm using demo as username and the IP address of the node that we are going to access, which is dev node. I'll simply open it, the profile, and I will be able to access it from outside. Before we start talking about Docker build operations to create Docker images, let's first understand the Docker file. What all the sections, what all the information that we need to define in the Docker file, because ultimately Docker file is going to be the source of truth for the Docker daemon to create the Docker images. So now let's move on to our slide once again and try to understand what all the fields needs to be defined in the Docker file. So this is one Docker file, very simple Docker file, because I'm not going to include so many information, because I just want to give you a very basic understanding about the Docker file first. Once you are able to understand the Docker file and able to create Docker images, then you can keep on adding the additional informations, feature and specification based on the requirement. As you can see, this is a sample Docker file. It has very basic, or you can say the mandatory sections only. I'm not going to cover so many things because I want to help you understand what is the Docker file and what is the basic minimum information must be there in order to convert a Docker file into image, functional image, not just image. Okay, so for that purpose, as you can see, I have defined this Docker file into multiple sections. And the first and most important section is the from section. What does it mean? This from section defines like what is the base image or OS needs to be used for this particular container image that is going to be built. Now you might be thinking, previously I said Docker or container need not to have a complete operating system on it. That is true. But here we are not going to install a complete operating system. Rather, we are going to utilize the kernel function, kernel component of that particular operating system. And this from function is indicating that this whatever information, whatever OS that we are defining here will be pulled from the Docker Hub public repositories. We need not to define the path and all. We just simply need to define what is the image name of the OS or kernel that we want to use, and it is going to by default connect to the public repositories of the Docker Hub registry, and it is going to pull it. Then the second important section is the commands that we want to execute. Remember we said, right? We said A Docker file must have three sections. One is the OS or kernel information that needs to be used. The second is what all the commands that we want to perform in order to update the applications and packages, libraries, or install the applications and packages. And then what all the additional configurations that we want to perform. So these are minimum three sections that must be defined in a Docker file to create a functional Docker image. So here we, as you can see, we are performing certain we are using run functions to perform certain commands execution. We will talk about all these commands when we start writing the actual Docker file. Here I'm just trying to explain you what all the sections are there and what is the purpose of that. So first section is used from function that is going to define what is the images, base images or OS or kernel is going to be used in order to make this Docker image functional. Then the second, we are defining what are the commands that we want to execute in order to update the libraries and packages or install the packages also. Then the third section is basically what all the additional commands that we want to perform that we are going to define here. Those are related to configurations, instructions, etc. And at the last, we are performing expose section. We are using expose function here. This is optional, but actually it is mandatory also. I will explain why I'm calling it optional and also mandatory. Okay, so basically this particular section is going to be used to expose whatever the services running in your application or container. Let's say you are making a container for HTTPD. That means HTTPD, if you are using at port 80 or port 443, whatever port you want to use to expose that particular HTTPD service to the outside, that port needs to be defined here to expose the service that is running in your container to the outside world for the functional use case. Okay, now if you don't want to expose any service, you want to have a container for your testing purpose only. Okay, in that case you need not to expose any service. So that means in that case it will become optional. But if you are going to expose a service, in that case it is mandatory to have. So these are the 4 fields that must be there in a Docker file. You can choose to skip section 4, but if you need to expose the service, it must be there. In addition to these sections, you can have multiple additional sections also in order to define additional metadata or information to that particular Docker image that you are going to build, along with the system specification, which with that section you can define what all the CPU, RAM and storage you are going to allocate to that particular container. I'm not going to cover all those parts here because in order to define a proper structured Docker file, you need to work along with your dev team to understand the requirement of the container or system specification based on the application requirements, application performance and compatibility things. Just because we are going to use general applications to help you understand what is the Docker file, and what is the Docker image and how it is going to work. So we are not going to include those many sections because those are not useful here. But if you are writing your prod grade file, your developer will be telling like what all the values, what all the specifications they need depending on their requirement, or you can mutually sit with them and decide what all the fields needs to be included in the Docker file. Now let's jump on to one of our Docker file that I have already written to show you what all the actual configurations are there. So let's minimize this. So this is the folder that I have created in advance to save time, and I have created few Docker files here. So as you can see, I have 2 directories. One is the HTTP sys and the other one is Ubuntu sys. I'll open Ubuntu sys first and then we'll come to the other folder. I'll open this file, which is a Docker file, as you can see here. I'll open this. Here it is. As you can see, as I explained in slide right, this also contains 4 sections. And in first section, we are using from function to pull the image, which is Ubuntu as an operating system, or you can say Ubuntu based kernel, and the version is latest. That means with the help of from function, this particular Docker daemon is going to connect Docker Hub registry, and it is going to look for public registry which is named as Ubuntu and the image which is having tag latest. And I am creating this particular Ubuntu system to be used as a test system so that we can perform additional testings and validations after creating the Docker image, and then when we are running it as container. Because in order to perform validations and testings, we need additional tools. That's why I'm specifically creating a Ubuntu system with these many tools. But in actual Prodgate system, you may or may not be needing it depending on your requirement. So just keep in mind, I'm just creating a sample Docker file with necessary tools that I am going to use to perform testings and validations to show you end-to-end demo. I'm going to again perform the apt get install command using run function of the Docker daemon, and then I'm going to install DNS utility so that we can perform dig to validate what all the DNS are being used. Then I'm going to perform telnet as a tool, and then OpenSSH server and sudo IP utilities, ping and curl. So these are the additional tools that I'm going to install in my container image that is going to be built, so that once the Docker is going to use that image as container, my container will be having these many functionalities. Now in section 3, we are going to define certain additional things, like we are going to create, because we are installing OpenSSH server. There is a reason for that. The reason is I want to access this particular container once it is running from outside of the event Docker daemon itself, so that we can perform a proper testing, like how it is working, how it is functional, everything we will be able to understand, and we will be able to differentiate between the multiple ports and all. So that's why I am using this particular OpenSSH service and application here. Now just because OpenSSH service is running and installed, I need to configure it. I need to create username and password, etc., and start the services so that we can access the SSH service from the outside once the container is running. Just because OpenSSH server uses port 22 to be used as a SSH service, you know, right? The SSH service uses port 22, TCP 22. So I'm using expose function to expose my port 22 outside the container. This is the section which is indicating whenever my container is running, it must activate this particular service in the backend, so that whenever we are accessing, we should get the prompt of this particular terminal or OpenSSH server. So this is one of the file that I have created. Similarly, I have created one more file. I'll talk about that also, which is HTTPD server, HTTP servers. I will open the Docker file first. So this again going to have same four sections, because out of these four sections, these are the mandatory sections to have, and this you can choose to have or not to have depending on your service requirements. Here in Ubuntu system, I am using Ubuntu latest version. Here you can see I am using CentOS as an OS for kernel, and then CentOS 7 as the version of it. We are performing again update command, and we are going to install HTTPD package. What I'm going to do is, with this command, I'm using copy function to copy. This is my index.html which I have created. I'll show you what is there in this, to copy in the var.www.html directory, so that whenever we are accessing this particular service from outside, we will be getting a page to validate it. Similarly, we are running this particular service in the background, so that whenever my container is running, my service should also run by default. Then just because I'm using HTTPD that runs on port 80 by default, I'm exposing port 80 so that I can access the service from outside and validate whether we are getting the desired page or not. Let's look at the index file. So this is very simple index file. It is not much thing defined here. You can see I'm just defining a body color which is orange. Just I defined randomly. You can change it to, and then I'm defining a body message, like whenever I'm accessing the page, I should get this message on it. So I'm saying, hello, I'm a container inside a KTS pod. However, it is going to be a Docker image. We have not yet even talked about the KTS, but still, just because later we are going to use the same images to demo or hands-on for our KTS environment also, I am naming it as KTS pod. You can change it if required, otherwise let it be. It is not a big deal. Okay, so I'm not going to change it. It is just a message that I want to display whenever I'm accessing that particular service. Now what I'll do is I'll close all these things, and now let's go to our virtual box that we had accessed, terminal. I'll show you one thing. First of all, I will perform docker image ls, and it is going to give error because my docker service is not running. So first of all, whenever you are rebooting your system, make sure that your docker service and containerd service must be functional. I will start these two services first. So sudo systemctl start docker and container d. So you need to remember this. If you are getting this error, that means your Docker daemon service is not running. You need to start it. There are ways to start it, like you can apply the cron job and all, schedule the cron job whenever your system is turning on. It should run in the background and your service should start automatically. But I did not do it intentionally because I wanted to keep this thing, feed this in your memory, that you must make sure that your your Docker daemon service and container D is running. Then only you will be able to perform Docker functional commands. If I'll perform Docker image ls again, I'm getting response. That means my command is functional now. If you want, you can validate the status of your service also using status command. You can see my services are running. Now what I'll do is, let's first of all create two directories here. mkdir. I'll tell you why I'm creating two directories later, but not now, so that you can understand in better way. So mkdir, I will create one directory for Ubuntu system, and I will create another which is for web system. ls, I have two directories. What I'll do is I'll go into, let's say, I'll go into my Ubuntu directory first. What I'll do is, now I'll create a Docker file here. So in order to create that, I will do one thing. I will simply use one of the Docker file that we have already defined. We'll open it. I'm not going to type it. I will simply copy everything and will paste it on the terminal in my file. So what I'll do is, I'll use just because I installed nano editor, I'm going to give some file. Let's say I'm going to give the name of Ubuntu sys. Ubuntu sys is my file name. I'm going to paste everything here. Just copy it from there and pasted it here. I'm going to save this file. Now I'll go back. I'll exit from this particular directory and I'll go into other directory, which is the web system, cd web system. Again, I'll perform the same thing. I'll close this. I'll go back to my Dockerfile folder. I'll go to httpd. I'll open my Docker file of http notepad. I'll copy everything from here and then nano. Again, I will, let's say, name it websys. Paste everything here, save, exit. Then just because it has one index.html file also, I need to copy that too. Whatever the contents are there in this. Again, I'm going to open it in notepad, select everything, copy, go back to terminal, nano, file name, index.html, and then paste everything, save, exit, and then go back to our root directory. ls, both the directories are here. I'll close this because these two files are not needed anymore, because we have transferred or copied and pasted these informations to my dev system. Now my dev systems are having two files. Now by this time you are able to understand what is Docker file, what all the fields and information it must have, what all the additional information it can have, whether you should use export function, whether you should expose function or not, it depends on your requirement. And adding additional fields also depends on your product and application requirement. You can find detailed information about the Docker file in the description box. I will add the link of the what all the fields that you can include, what all the function you can utilize in the Docker file. Now what I'll do is, let's get into Ubuntu directory and try to create the Ubuntu image. Try to perform Docker build operation to create a Docker image using the Docker file that we have created for Ubuntu sys. Okay, now let's do one thing. Now let's first clear the screen to start from beginning. Okay, here we are. So what we did is, we entered in the Ubuntu system directory first, and then this contains a file which called Ubuntu system, and it is a Docker file that contains all the information that we had defined. In order to create a Docker image, we need to execute Docker build operation, and the command is docker image build. This is the command followed by -t. -t is indicating the tag that is going to provide a name to that particular image that is going to be built, and then followed by the name, whatever name that we want to give. Let's say again we are going to call it Ubuntu sys, which is the image name also. And then we need to provide the path where the file exists. Okay, so I'm going to define, let's say my file name is Ubuntu sys. I'm going to execute this command. So as you can see, I'm using docker image build function -t as a tag, and this is the name that is going to be used as tag. Then this particular section is indicating root directory, local directory you can say, and then this is the file name that we have created for, which contains the docker build related information. Now it is going to fail. I'll tell you why. You can say it is saying it attempted to create docker build image build, but it failed. Unable to prepare. Yeah, so it is saying basically it was trying to find the information from this path, but it is unable to prepare the context. Why is that? We'll try to understand that, but let's do one thing. I'll remove this particular file name and execute the command again. Now we got the different error this time. So you can see it attempted to build, and then it is saying finished with the error. What is the error? Failed to solve, failed to read a Docker file. Look at this particular word here, failed to read the Docker file, and that's why our process got failed. Now that's why I gave a name here, file name, which is Ubuntu sys. I wanted to make you understand that whenever we are performing Docker image build operation or function, by default Docker daemon looks for a file which is exactly named as a Docker file, like this. In the same order it should be defined. If we are going to give any other name, it will not able to find that particular file, and it is going to give error. Now in first command we defined the name also. Just because we had already given a name, it was aware that you are supplying a name, and that's why it didn't try to look for the Docker file, and it gave different error, that unable to prepare the context, because it was expecting a Docker file, but you had forcefully given a different file. That's why it gave different error here. But this time we simply defined whatever directory you are, within that directory go and find a file, and there must be a Docker file. But it attempted and failed to find Docker file, and that's why it is giving the error. And the reason is our Docker file, that means the file that contains the Docker build image information, must be named as exactly in this way. If we will name it differently, it is going to fail it. The Docker build function or creation is going to fail. This particular exercise I intentionally included because I wanted to understand, because many people rename, because many of us give a file name according to our ease, comfort and preference, and then we end up getting into this error and we spend the time to troubleshoot. I personally spend a lot of time because I was not able to understand why my function is failing. I had given different name and I was struggling for that. And then later I realized just because I'm using different name, my function is failing. So remember this particular thing, the Docker file must be named as the Docker file itself. Now, so what we will do is, we will not make any change to command. We'll execute this again. And then rather than that, we'll simply rename it, this file, to Docker file. So I'll use mv function. This is the file that is at present, and this is the file name that is desired. I have done it. My file name got changed. I'll execute the same command without even making a single change to it, so that you can correlate easily. Here we are. So you can see it is able to locate the file, build function is started. Now the first function, it is from function it is using, and it is going to connect Docker IO, which is of course the Docker repository public path, and it looked for Ubuntu latest version, it got it and started downloading it. And after downloading it, it is performing run. It is using run function to execute these commands to update the packages, and then later it will execute the installation commands, and then it will perform the configuration sections of it. You can see what all the things that we had defined is being performed. here. Nothing is being skipped until unless there is any genuine problem or something. So it is, if you feel like, right, it is happening like you are creating your own system, normal system. The same thing is happening. So technically in function you will not find major difference between your normal system and there. The only difference is in container, the or in Docker image, the packages, the applications, the kernel will be very limited in size and small in size. And just because we are not going to have complete operating system, we are just going to have kernel part of it. That means size of the OS itself will be less, and then we are going to have very few applications which are required to run your application. The dependencies, libraries, everything will be very limited. That's why the size of the container is going to be very less. And just because size is less, it is going to use very less compute resources, and that's why we call it micro compute instances, because it is very small in size compared to the traditional and then virtualized part of it. Now let it be created and then I'll show you the size of it. As you can see, my process got completed, and now I'll execute docker image ls command that you can use to list all the things. You can see we had given this as a tag which got created as an name here. Then tag latest, I'll talk about it. We had given Ubuntu sys as tag, but here it is showing tag latest. I'll explain you why it is happening. Then the image ID. Every image will have alphanumeric unique ID generated for its identity within the system. Creation, it got created 12 seconds ago, and this is the size. You see how small it is. And despite, just because we have added so many additional libraries and packages, it is this big. Otherwise it would have even smaller than this. Okay, so this is the size. So that means in order to run a complete system that is having this many size only, you can assume like how much compute resources it is going to consume. So that's why it is a big advantage in terms of the cost optimized infrastructure. So once that is done, now let's go back to our other directory, which is the websys. You can see this is also having a file name websys. That means we need to rename it. Now let's do that. Now you might be able to understand why I created two different directories for my two different Docker files. Because as you see, Docker file must be exactly named as Docker file. And a single directory cannot have two files with the same name. That's why we had to create separate directory for each Docker file that you want to have. So now I have created Docker file here. Okay, and before I execute Docker build operation for my web system, I'll make one more change here. I'm going to change this particular file name also. I'll make it to something else. I will explain why I am doing this, because I wanted to show you something here again to make you better understand, so that you will not make mistakes while doing the functions. Otherwise we will end up spending additional time in order to find the reason. Okay, now what I'll do is, this is my status as present. I'm going to have a Docker file and an index.html. Now I will use history command to find what is the command that I have used to create my Docker file. However, I remember it, but I am intentionally going to use this. See, I just copied it. I'm just going to change the name of the image. That means tag, nothing else. I'm not changing anything. Rest all remains same. The moment I will execute this command, I'm going to get error again. Here we are. So why we are getting error? Because it attempted to create, the moment we entered the command, executed the command, it attempted to create, it did many things. You can see it performed 8 out of 8 functions or tasks, and then at the end it failed. Why it failed? Because at the fourth task it was trying to copy index.html from my root directory, that means local directory, to the var.html, www.html, so var/www.html directory in the my container or the system, that whatever you want to say. Now the problem is, just because I renamed the index.html, and you can say this was the command that failed in execution, and that's why build process got rejected or failed, because it never creates a container image with half of the information. That's why it is failed. Now the reason is because we renamed it, and as you remember, right, we had defined this command and we had given different file name. That means whatever the information is defined in the Docker file, it must be realistic and in place. If you are going to supply any non-realistic or invalid information, your build process is going to fail. Okay, that is the purpose of showing this particular exercise. And that's why I call Docker files are going to be the source of truth in order to build your image, Docker image. Okay, so now we'll go and correct it. The change that we had made, we are going to correct it, and then we'll execute the same command again. Here we are. So what we do is let me show you. I rename the file back to index.html. Nothing else. I'm not going to make any other change here. I will simply rerun the same command. Here we are. Done. You can say my image got created successfully and very quickly. Let's go and perform docker image ls to list the images that it has. We can see we use a docker image ls command to list all the images that we have. We have two images. One is Ubuntu sys, one is web sys, tag is latest, image id is this, and these are the sizes that we have. So that's all. So this all defines the Docker build operation. That means Docker build operation includes writing a Docker file, then executing Docker build command, image build command to create. That's all for the day. Hope you enjoyed watching. If you find it useful, please encourage us with your comments, likes, shares, and subscriptions. Thanks for joining. Stay tuned for more videos.